All right, so today we're still working with linear systems, and we need to solve the linear system, meaning we need to find out where these two equations cross each other. If we were to graph it, we want to find their intersection. So meaning that we have to find the x part and the y part and where these two equations cross each other. Now there's a mathematical way to do that, and we've worked with graphing, we've worked with substitution. Today we're going to learn about elimination. And the whole point of elimination is we need to eliminate a variable from the problem. Then from there we can add the equations together and work with one variable at a time. But the key is that we need these inverse terms. So the terms have to be they have to be the same, like so in this case it's 4y, but 4y is a positive and we also have a 4y that's a negative. So that's inverse. Inverse means for addition and subtraction when they're opposite signs. So it's the same 4y, but one of this positive, one of this negative. And when we have the inverse, that means we can add these equations together, and this is what we're going to get. So 10 plus negative 8 is 2x. 4y plus negative 4y equals 0y, and negative 20 plus 16 is going to be negative 4. So the whole purpose of elimination, or why we're doing it this way, is that we need to eliminate one of my variables and look at y. 0 times anything equals 0, so I can eliminate y from the equation. And now all I have left is 2x equals negative 4. Then how do I solve for x? Divide by 2. And x equals negative 2. So that's how we use elimination. We use it to line up, again, two terms that are exactly the same except they're inverses of each other. One's positive, one is negative. So now, again, we're not done because with the system, we don't just find one thing. We have to find two answers. So we found x, and we need to plug x in. Now, we could plug it into the top equation or the bottom equation. It doesn't matter. You're going to get the same answer. In fact, I'll go ahead and do both for you. So let's say I did plug it into the top. Okay, I would get 10, excuse me, Mr. Schwant. You plug in the negative 2 in for x. I plugged in for y. Whoopsies. I'm glad to fix that. So 10 times negative 2 plus 4y equals negative 20. Okay, so we first multiply the negative, or 10 times negative 2, which is negative 20, plus 4y equals negative 20. We then add 20 to both sides because they're on different sides. And so we do the inverse. So there's another place where we do the inverse. So 4y equals negative 20 plus 20 is 0. Now don't freak out. That's okay. 0 can be over there on the other side of the equation. We just need the variable to stay. So we just divide by 4. It's all good. And y equals 0 divided by anything is still going to be 0. So I have x equals negative 2, y equals 0. So that means my final answer is going to be an ordered pair, negative 2 comma 0. So remember, x goes first, then y. So elimination actually has a lot fewer steps, but you have to make sure you have two equations that are all lined up. Notice that the x's are lined up, the y's are lined up, and the numbers are lined up. And you have to have one of the terms, one of the variables, be inverses of each other. And like I promised, I'll go ahead and plug it into the bottom equation. We're going to get the same answer. So let's plug it in there. Okay. So I have negative 8 times negative 2 minus 4y equals 16. Negative 8 times negative 2 is positive 16. Minus 4y equals 16. Subtract 16 from both sides because they're on different sides. Negative 4y equals 0. Divide by negative 4, that's okay. And y equals 0. So we got the same answer. Doesn't matter which equation we use to plug in. So again, my final answer is negative 2 comma 0, and that is how you solve linear systems with elimination.